Okay, let's work on some determinants. Again, starting off again, if you have a 2 by 2 matrix, the determinant is A times D is the product of the diagonal minus product of the off diagonal. So BC. No, it's not equals, but rather this is the determinant of a 2 by 2 matrix. And we need that so that when we do a determinant of a 3 by 3 matrix, say 1, 3, 0, minus 1, 2, 0, put a 1 there, 2, 0. So if we want to do the determinant of this matrix, the best thing to do would be this column. But let's make it a little harder. We'll do two cases here. So this first one we'll do column 2. That'll be the most work. And for that, we're using these three numbers here. So we'll have a 3 times a minus 1 to the power of its address, first row, second column, first row, second column, times a 2 by 2 matrix. And the 2 by 2 matrix is the matrix you get by blocking out the first row and the second column. So it's these four numbers, minus 1, 0, 0, 1, plus the next number in our column, 2 times minus 1 to an address, second row, second column, times the determinant of a 2 by 2 matrix, which we get by blocking out the second row and the second column, leaving these corners of the matrix. So 1, 0, 0, 1. And then we have the last number in our matrix, plus 2 minus 1, raised to the power of its address, third row, second column, times a 2 by 2 determinant. And so we get that determinant by blocking off the third row, second column. So that's 1, 0, minus 1, 0. So if we reduce a 3 by 3 determinant down to a bunch of 2 by 2s. So what is this? So this is minus 3 times minus 1 minus 0 plus 2, that's a positive 1, times 1 minus 0 plus, that's always going to be minus 2, and then that's 0 minus 0. So what's this? This is positive 3 plus 2 minus 0 is 5. The determinant is 5. So that means it has an inverse. Now maybe I'll show you in the calculator how we do that in a minute. Let's do it an easier way using this third column. So then we'd have 0, whatever times stuff, plus 0 times stuff, plus 1 is address, third row, third column, times a 2 by 2 matrix that we get by blocking off the third row, third column. So it's 1, 3, minus 1, 2. So that's 6, that's positive. So this is going to be 2 minus a minus 3 is 5. So you can see it makes quite a bit of difference as to which ones you choose. A couple more things. All right, so if you ever have a row or a column of zeros anywhere in the matrix, this is a gimme. The determinant is going to equal 0 because you could choose that row. So in that sense, I could ask you a matrix, for the determinant of a matrix that was quite large, as long as it had a row of zeros or a column of zeros, it would be just instant. Another one, suppose I had negative 2, 0, 0, 0, 0, 1, 4, 8, 7, then 6, 2, 0, 1, 5, negative 3, 0, 8, 2, 2, 2, negative 1, 5, 0, 0, 0. So this looks like a pretty beefy determinant. If we choose the first row, then we'll have minus 2 times minus 1 to its address, first row, first column, times the 4 by 4 determinant, all right. Whoops. So that last row is really convenient. So we can say, well, this is minus 2 minus 1 to the 1 plus 1. The determinant of this thing, use the last row, is 5 times minus 1. It's in the fourth row, first column, 4 plus 1, times its determinant, which is 2, 0, 1, where we get it blocking this stuff out, 2, 0, 1, minus 3, 0, 8, 2, 2, minus 1. But this 3 by 3 determinant is fine if you choose this middle column. How are we doing here? So this is a positive 1, this is a minus 1, there's a minus. So this is 10 so far. Times 2, its address. This is the third row, second column. And then block those out, and you get a 2 by 2 matrix, which is pretty easy to do. This is a minus, so this is minus 20 so far, times 16 minus a minus 3, so that's 19. So this is minus 20 times 19, which is minus 380. Right? So it has an inverse. So in some sense, the determinant of this 5 by 5 matrix was easier than this 3 by 3. Well, not the fast way, but if you did it the long way. So I wouldn't, if I asked you something like this, there'll be a series of very good choices that make this very easy. There's also a series of very bad choices. If you choose the first column, then you have 5 4 by 4 matrices to take the determinant of. And if you choose this column, then you'd have another 4 3 by 3s. And if you choose, I don't know, this column, then you have 3 more 2 by 2s. You'd have pages of work to arrive at the same number. So the next video, I'll talk about using your calculator and stuff.